Welcome to another episode of Lineman Talk. Today we're going to spend a few minutes and we're going to talk about transformer impedance. What does it mean to you? Definition, transformer impedance, and how is it determined? So we brought a 10 kVA transformer, 2400 volt primary, 240 volt secondary. We've got a variac, we've got a 120 volt source, a voltmeter, and an amp meter. The secondary has been shorted. Right now we're applying 120 volts into the high side coil through this variac. But just like every video that we do, what is the most important thing? What comes first in these videos? Safety. So we'll get our PPE on, get our rubber gloves. You can see the amp meter. It's turned off. You can see the voltmeter. Now the 10 kVA transformer is 240 volt secondary. At 100% it delivers 41.6 rated amps. So when we do our test, we're going to drive this transformer until it develops 41 amps on the shorted secondary. So we're plugged into the wall. We're going to turn on our variac. The voltmeter shows less than 1 volt. Now we're going to start cranking it up. There's 10 amps on the shorted secondary. $41. See if I can bump it just a little bit. Okay, so we're going to settle with 41.8. The voltage is 34.37. So we'll come over here. We'll put our 34.37 and we'll divide that by 2400 volts. The answer is the percentage of impedance. 1.43% impedance. Now, transformer impedance is linear. So if I were to crank this up, right now we're at 34 volts on the primary. We're going to take the transformer to 200%, which would be 82 amps. And the transformer coil has been magnetized. We couldn't get this transformer ratio if it was not. Here's my 82. My math is, I'm at 83.2 and my math is 68. Now I'm going to start running it back down. .41 amps on the secondary current produces 34.05, still 1.4. The data plate on this transformer from the manufacturer said he tested out at 1.6. Now, I'm going to assume that every 10 kVA from this manufacturer is impedance 1.6. So what you've seen us do here is take the 10 kVA divided by 240 volts and know that the full load rating is 41.6. We apply a voltage to the high side coil that we control and measure until we get our 41 amps of full load current. Then we do our math and we divide the 2400 volts into the voltage that it took feeding into the transformer to create that 41 amps, and we arrived with the transformer impedance. So when you see a transformer that has a 2.0 or a 4.0, at the rated current, that is the voltage drop in percent that it costs to operate this transformer. So when we look at this transformer at 1.6, the voltage drop starts right here. And then you have your secondary leads that bring in more voltage drop, but what we can guarantee is that at 100%, 41 amps, I've already lost 1.4% before I left the transformer. If you had any questions about this, I think this covers how it's produced, how it's determined. So thank you for your time, and I appreciate you being here. Look forward to seeing you on the next episode of Lineman Talk.